Good morning, students. This is Mrs. Sadi Joseph, your physics teacher. Welcome back to the online teaching for the session 2020-21. Let us continue with the same chapter, that is chapter 11, work and energy. The previous video I had explained when we can say work is done, what is energy, what are the different type of energy, what is kinetic energy, and the expression for calculating kinetic energy. Let us recall it one by one. When a force is applied on an object and it moves at a distance, then we can say work is done. We can calculate the work done by using the formula W is equal to F into S, where F is the force applied on the object and S is the displacement of the object. There are different type of work done, that is positive work done, negative work done, and zero work done. What is energy? The capacity to do work is called energy. The different type of energy are light energy, mechanical energy, sound energy, wind energy, etc. The sum of kinetic energy and potential energy is together known as mechanical energy. What is kinetic energy? Kinetic energy means the energy possessed by a body by its motion, or all the moving objects possess kinetic energy, and we can calculate the kinetic energy of an object by using the formula Ke is equal to half mv square. Now let us solve some numericals related to these topics. Our first question is example number 1. A force of 5 Newton is acting on an object. The object is displaced through 2 meters in the direction of the force. If the force acts on the object all through the displacement, then what will be the work done? You know that work done, W is equal to force into displacement. Here what is the force? 5 Newton, and the displacement is equal to 2 meters. So 5 2s are 10 Newton meter, or it is also known as 10 joules. 1 Newton meter means 1 joule. So here the work done is equal to 10 joules. Let us solve another question. That is example number 2 of your NCERT textbook. A porter lifts a luggage of 15 kg from the ground and puts it on his head 1.5 meter above the ground. Calculate the work done by him on the luggage. Here in this question, mass of the luggage is given as 15 kilogram and the displacement S is equal to 1.5 meter. When you lift the luggage at a height, you are doing work against the gravity. You know that work done is equal to force into displacement. But force is equal to mass into acceleration into S. So what is the mass of the object here? 15 kilogram. Here acceleration means acceleration due to gravity, that is equal to 10 meter per second square into what is the displacement? 1.5 meter. So 1.5 into 10 means 15. 15 into 15 is equal to 225 joules. Work done, the unit is joules. So your answer is 225 joules. Is it clear, children? Okay. Moving on to another question. Example number 3 of your textbook. An object of mass 15 kilogram is moving with a uniform velocity of 4 meter per second. What is the kinetic energy possessed by the object? Here, mass of the body is given as 15 kilogram and the velocity is 4 meter per second. So what is the formula for calculating kinetic energy? Kinetic energy is equal to half mv square. By substituting the values of mass and velocity, you will get half into 15 into v square means 4 into 4. So that is equal to 120 joules. So when you simplify this, you will get the answer as 120 joules. One more question. What is the work to be done to increase the velocity of a car from 30 km per hour to 60 km per hour if the mass of the car is 1500 kilogram? So here mass of the car is given as 1500 kilogram and the initial velocity is given as 30 km per hour. So this 30 km per hour, you have to convert it into meters per second. You know that 1 kilometer is equal to 1000 meters. So 30 kilometer is equal to 30 into 1000 meters upon 60 into 60 seconds, since 1 hour is equal to 60 into 60 seconds. And when you simplify this, you will get as 25 upon 3 meter per second. Similarly, the final velocity of the car v is equal to 60 kilometer per hour. Again, we have to convert this into meter per second. So 60 kilometer per hour is equal to 60 into 1000 upon 60 into 60 seconds. 60 and 60 will get cancelled. 0 and 0 will get cancelled. 3 2s are 6 and 50 2s are 100. So that will be equal to 50 upon 3 meter per second. Now calculate the initial kinetic energy of the car. As you know, kinetic energy of a car is equal to half into mass into velocity square. So here velocity means initial velocity of the car. By substituting the values, you will get half into 1500 kilogram into 25 upon 3 the whole square. And when you simplify this, you will get 1,56,250 upon 3 joules. Now let us see what is the final kinetic energy of the car. Kinetic energy of the car is equal to half into 1500 kilogram, that is the mass of the car, and final velocity is 50 upon 3 meter per second, the whole square, and that is equal to 6,25,000 upon 3 joules. Therefore, the work done is equal to change in kinetic energy. That means final kinetic energy minus initial kinetic energy. That is 6,25,000 upon 3 joules minus 1,56,250 upon 3 joules. When you simplify this, you will get the answer as 1,56,250 joules. All of you solve these questions in your notebook and see. If you have any doubt, you can ask me. I will explain it again. This is the end of today's module. I will explain the rest of the chapter in the next video. Till then, thank you, bye bye, and take care.